Welcome. So, this particular course is basically a graduate level course. That means this is the course that you take during your MTech and your PhD times. The course title is Heat Transfer and Combustion in Multiphase Systems. My name is Professor Saptarshi Basu. I am a faculty member at the Department of Mechanical Engineering at Indian Institute of Science. I am also an associate faculty member in the Interdisciplinary Center for Energy Research. Okay, in addition to that, I am a DST Swarna Jayanti Fellow in Engineering Sciences. So, this particular course, what it will do is that, okay, let me just, first let us talk about the course outline a little bit. So, in this particular course, we will sequentially cover a few things which you normally may or may not have seen in your other graduate level or undergraduate courses. So, the first thing that we are going to cover is that we are going to look at multiphase systems, okay, and several special applications of the multiphase systems in details during the course, during this 20-hour course. Okay, so, first what we are going to look at, we are going to look at the thermodynamics of the multiphase systems, look at what multiphase systems are and what kind of multiphase systems would you normally experience in your day-to-day life. And frankly speaking, there are n number of multiphase systems. In fact, all your power production devices or your energy production devices, all your household equipments, all your household things that you see probably has got multiphase inbuilt into it in one way or the other. Okay. For example, for power generation, let us take the gas turbine application. In a gas turbine application, what do you have? You basically have liquid fuel being sprayed, okay, into a combustor where it is ignited, it burns, and that is how you get propulsive power or power generation, depending on whether it is aero propulsion or land based power generation. So, that is gas turbines for you. Let us assume, say for example, you want to create a patterned surface, as is the thing in the case of in the new age of nanoelectronics, microelectronics. Okay. In that case, what you do, you basically use multiphase systems, in this case droplets, basically to generate patterns of different kinds. Let us take the examples of pharmaceutical applications like drug delivery. Okay. Let us also take the example of point of care diagnostics, okay, which use microfluidics. All of these include multiphase systems. Okay. And in multiphase systems, there are basically several things. You have heat transfer, mass transfer, you have fluid mechanics of the problem, and in addition, for power generation and other related applications, you have combustion. So, in this particular course, we are going to go through all of these things, okay, in some details. So, first we are going to look at what are the different types of multiphase systems that we see around, what are the interfaces that are involved in such multiphase systems, okay, why the multiphase systems are so difficult to tackle. Then we are going to look at the thermodynamics of multiphase system, the thermodynamics of the interfaces, look at the key interface phenomena, okay, that what are the interface phenomena that we see. Then we are going to look at the governing equations, the conservation equations, how those conservation equations are written for multiphase systems. Can we actually volume average or mass average or area average those or phase average those governing equations to simplify the problems at hand. Okay. So, apart from looking at the thermodynamics of the multiphase systems, we are also going to look at the interfacial phenomena, the key concepts that are related to interfacial phenomena, then the generalized governing equations, how those equations actually applies for multiphase systems, how we can actually phase average those equations, how can we volume average those equations, how we can simplify those equations to meet certain requirements, how we can basically simplify the problems. Okay. Then apart from that, we are going to look at the transport processes at the interfaces, look at the key concepts behind those transport processes, define quantities like surface tension and other things, okay, which are basically key players, look at the dynamic behavior of those interfaces, looking at instabilities and things like that. Okay. We are also then going to look at some of the specialized interfacial transport processes, like for example evaporation, okay, condensation and things like that. Then we are going to go into some special topics, like for example how a droplet for example evaporates. Why the droplet physics is very important? Because droplet is the most common form of multiphase systems that you will see. It is there in sprays, it is there in drug delivery, it is there in microfluidics, it is there in thermal barrier coatings, It is there everywhere. So droplet is the most common form of multi-phase system that you will encounter. So we are going to look at how a droplet evaporates, what is the fluid dynamics within the droplet, how does a droplet actually transfer heat, mass and momentum with the surroundings, what are the dynamics that are involved. So we are going to devote a whole series of lectures on this. Then we are going to look at droplet atomization. Atomization is a very interesting concept, because with atomization this is what you do in any application, so to say. So you basically atomize fuel into a gas turbine combustor. You basically use atomization to basically generate nanoparticles, to generate milk powder, for example. So from food industry all the way up to electronics industry, atomization is a very common process. So that is what we are going to use. We are going to study what are the atomization models, what are the different key parameters or the key physics of atomization. After that we are going to spend some lectures on the droplet combustion. So droplet combustion is an important aspect, because that is what generates you the power or propulsion, whatever you think about it. What are the regimes of droplet combustion, how droplet combustion is actually different from droplet vaporization, what are the key physics that are involved. So we are going to go through that. And lastly we are going to take a look at boiling. Okay, so the different categories of boiling. But boiling is something that is there everywhere, including from nuclear power plants all the way up to normal cooling applications. You have boiling, because boiling is a very aggressive mode of heat transfer. Okay, so we are going to study boiling in a lot of details, okay, for about 2 or 3 lectures, 4 lectures actually, where we are going to study that how boiling is actually used. Okay, what are the key concepts of boiling, what are the regimes of boiling, etc., etc. So in this particular course we are going to start from a very basic thermodynamics, then go into the mathematical details, understand the key concepts of interfaces, how the interface happens, why there is an interface, what are the equations, what are the continuity equations that you can write at the interface, okay, how you can describe an interface, and then look at certain specialized applications like droplet vaporization, combustion and boiling, to apply some of those physics that we have learned and apply it in certain special applications and see that how we can analyze those systems. Okay, so that is what has been the motto of this particular course. So if you look at the slide now, okay, the lecture materials are largely adopted from the following 3 textbooks. Okay, so Amir Faghri and Yuan Zhang, 2006, Transport Phenomena in Multiphase Systems, Elsevier Academic Press. So this is the main book through which we will cover the thermodynamics, the governing equations, boiling and interfacial phenomena. C.K. Law's book of combustion physics, Cambridge University Press, we are going to use it exclusively for droplet combustion related studies, okay, and combustion fundamentals. William Chirignano, Fluid Dynamics and Transport of Droplets and Sprays, again Cambridge University Press, we are going to use it extensively for droplet vaporization, okay, vaporization and droplet liquid dynamics, the liquid phase transport. Okay, so most of the materials that I will show will be adopted from these textbooks, including figures, charts. Okay, during the course of the presentations we will show various types of charts, okay, which will be taken from these sources. Further readings, Nasser Asgrid's 2011 Handbook of Atomization and Sprays, Theory and Application, Springer Science and Business Media Production. So that will give you a lot of idea if you want to study atomization and sprays in detail. Some of the materials are also adapted from this. Okay, then there are further readings like Stephen Turn's Introduction to Combustion and F.M. White's Viscous Fluid Flow. All of these books you can actually study for further references. Okay, so the prerequisite for this course is that you should have a reasonably good understanding of heat transfer, combustion and fluid mechanics. So these are the 3 courses that you should have taken earlier, okay, in some form, whether it is in undergraduate or graduate doesn't really matter, but you should know a little bit about viscous fluid flow, you should know a little bit about heat transfers, particularly convective heat transfer, and you should at least have taken a basic course in combustion. Okay, so these are the basically 3 prerequisites, okay, materials that you need in order to understand some of the subtleties of this particular course. Okay, so as I said, most of this, so we have covered materials mainly from these textbooks. We have taken materials and have tailored it to meet your requirement. So, you can always read these textbooks in details if you want to know further, because this is a 20-hour course and these materials are quite extensive. So, you can actually, if you want to know further or you want to go into more details, more detailed math for example, you can actually go through these courses. The course will have physics and math almost in equal proportion. So, there will be some key understandings which you need to get, okay, especially in the thermodynamics and in the fluid mechanics part. But at the same time there will be certain amount of math that will be also involved, which we will derive. Sometimes we will state the results in the interest of time. So, some of those materials you can do it at your home as a part of practice, that how those derivations are obtained. Some derivations will be done, some derivations will not be done, but they will be stated. Okay. So, this is the overall texture, the overall idea about this course. So, this is going to give you that insight that how multi-phase systems actually work. So, from an insights at different scales, different physics to certain applications, but applications are also not very applied applications. These are specialized applications like droplet vaporization and boiling that we are going to cover during the course of this 20 hours of lecture. Thank you.